that if a squared plus b squared equals c squared, then we do have a right triangle. So in this problem, they're asking us to substitute each of these numbers for a, b, and c. So the only thing that you need to make sure is that we're substituting the largest number for c. So if I substitute 4 for c, 4 squared plus 6 squared equals 10 squared. And so I have 10, this is the largest, so this has to equal c. Okay, we have that. So if I take 4 and square it, I have 16 plus 36 equals 10 squared, which is 100. 16 plus 36, 6 and 6 is 12. Carry the 1, 3, 4, 5. 52. And then we have 100. And then these are not equal. So if they're not equal, then we do not have a right triangle. So with this one, we only had to substitute one of the sets of numbers in order to see if we had a right triangle or not. Excuse me. Okay, now we have an investor puts $2,500 into a life insurance policy that pays 8.5% simple interest annually. How much interest should the investor expect at the end of 10 years? So if we are looking at what type of interest, we have how much, that it was simple interest. This is to help us determine which formula we're going to use. So I'd like you to draw a little box here. And in this box, I want you to write S for simple, C for compound, I for interest, and A for total amount. So when we're looking for simple interest, we have the formula of I equals PRT. And for simple total amount, we're going to have A equals I plus P, interest plus principal. For compound interest, I'll start with the compound total amount, which is the original formula that we know. A equals principal times 1 plus R to the T power. And compound interest, if we're looking for interest, we take our total amount and then we subtract our principal. So in this one, it's asking us to find how much interest should the investor expect to see at the end of 10 years. So he's using simple, and we're using simple interest. So there's our formula there. So when I substitute, here's my formula, I equals PRT. So when we substitute, we have this for our principal, 8.5 for our rate, and 10 years for our time. So when I substitute, I equals 2,500 times 8.5, but 8.5 has to be as a decimal, so 8.5 divided by 100, that's going to give me 0.085, and then our time is 10 years, so I'm going to have to multiply 2,500 times 0.085 times 10. And that's going to give us, so here's my substitution. And my solving, when I multiply all the way across, is $2,125. So here we have 21,000, that's not right. Here we have 212, and here we have 2125. So we're going to be left with B as our final. Okay, this says an employee in a retirement account that offers 9% interest compounded annually. The employee makes no additional deposits or withdrawals. Which amount is closest to the total the employee will have in the account at the end of 5 years? Okay, so now it says that we are going to use compounded. So this is going to give us I'm going to scroll up to our other chart right here. So we have compounded annually. So we have compounded and then compounded annually, which will put us in this box here. And it's asking for amount. So A represents total amount, so that is the formula that we're going to use. Formula was A amount, total amount equals principal times 1 plus the rate raised to the time power. So when I substitute the numbers that I know, we have 5,000 is our principal, 9% is our rate, and 5 is our time. And our rate, again, our 9%, we have to divide this by 100, and that's going to give us 0.09. Another way to look at that is 9, and the decimal's there, so I have to move it 2 times to the left, and then we will have 0.09. So when I substitute, I have A equals principal of 5,000, and then 1 plus 0.09 raised to the 5th power. So from here, we're going to take our calculator and substitute them just like this. And if I wanted to simplify just a little bit more, I could take this and say 1.09 to the 5th power. And then that's just multiplying 1.09 times 1.09 times 1.09 times 1.09 times 1.09. And then I'm going to take this number and multiply it by 5,000. And this, when I solve this, I'm going to get 7,693.1. So A equals 7,693.119. But if you see here, all of these are rounded to 2 decimal places. So if it's 5 or more, so I only have room for this many decimals, but I have to look at this decimal behind it and say, if it's 5 or more, you raise the score, 4 or less, let it rest. So we'll be left with 7,693.12. And that is right here. Okay. So here we go. Andrea invested $1,000 in a savings account. After 4 years, the account had earned a total of $112 in simple interest rate. What was her interest rate? Okay, here we have a little different of a situation because we're talking about simple interest, which gives us our formula of I, interest, equals principal times rate times time. But the things that they're giving us are not P, R, and T. So I equals, P equals, R equals, and T equals. We have an initial investment, which is our principal, is $1,000. We have a time of 4 years. And she earned a total of $112. So this in simple interest. So this is going to be our I. It's 112. But when we substitute this into our formula, we're going to have to take the I and substitute it here. 112 equals 1,000 times our rate, which we do not know, and then our time of 4 years. So in this, we have to combine the terms that we can combine. So on the right side of the equation, we're going to take the 1,000 and multiply it by 4. Since I can't just multiply the R right now, since I do not know it, this is our unknown. And so 1,000 times 4 is going to give us 4,000, and this equals 112. But remember, we still have this R, and this 4,000 and this R are being multiplied. So in order to get the R by itself, when we solve this, we're going to have to divide both sides by 4,000, because division is the inverse of multiplication, and that will give us 112 divided by 4,000. This will give us R equals 0.028. But then we have a problem, because they were seeing all of these answers are in percents. So all of these are giving us percents. So we're going to have to, in order to turn a percent to a decimal, you have to multiply. We're going to take 0.02. Oh, sorry, I think I wrote the wrong. 0.028. Sorry, I wrote 0.028 and multiply this by 100. And when we do that, we're going to move the decimal place 2 times, so we'll be left with 2.8%. And we'll be left with A. Alright, that's the last one here. Now we have point J is -4, -6, and point K is 4, 4 are located on a coordinate grid. Which measurement is closest to the distance between point J and point K in units? So now first we're going to have to plot this on the grid. So we have -4 and -6. This is our X and Y. So we're going to count here 1, 2, 3, 4, 5. Oh, sorry. 1, 2, 3, 4. And then since it's a -6, we'll go from 4, and then 1, 2, 3, 4, 5, 6. So here is our point right here. And then we have 4, 4. So we have our X and our Y. So when you plot on a coordinate grid, you plot your X, you move along the X-axis first, and then you move the Y-axis based on if it's positive or negative. So we have 1, 2, 3, 4, and then 1, 2, 3, 4. So 4, 4 is our coordinate point right here. So in order to find the distance between this, there's one tool that we could use, and that is the Pythagorean theorem. So I'm going to zoom in. So if we can create a right triangle from this one, we could extend our line here all the way up to 4, and then across this way we have just created a right angle, and then we can look at the distance between these points. So now we have a triangle A, B, and C, because the right angle always points to the hypotenuse, which is C, or the longest length. So as we count these, we have 1, 2, 3, 4, 5, 6, 7, 8. So we have A equals 8, and then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. B equals 10. So with our formula, A squared plus B squared equals C squared. When we substitute, we will be able to plug in 8 squared plus 10 squared equals C squared. And then when we simplify that, we're going to have 8 squared, which is 64, plus 100 equals C squared. 64 plus 100 equals 164 equals C squared. And then in order to find C, since they're only looking for C, we're going to have to take the square root of both sides. So the square root of C squared equals C, and the square root of 164 is 12.806. And so when we look at our answer choices, it says which measurement is closest to the distance between point J and point K. So all of these are rounded to just 2 numbers, so no decimal, or I guess not 2 numbers, but no decimals. So we're going to have to, we only have room for 2, so we have to look at the decimal that's next and say 5 or more, erase the score, 4 or less, let it rest. So this would round to 13, and then we'd be left here. Okay, now we have the width of a rectangle is 4 feet, and the diagonal length of the rectangle is 13 feet. Which measurement is closest to the length of this rectangle in feet? Okay, let's look at, first let's draw a rectangle. So the width is the width is 4 feet, and the diagonal length of the rectangle, so they took this rectangle and they divide it into two congruent triangles, and then we have a diagonal of 13 feet, and they said once we have a rectangle, we have right angles in all of the corners, but with this one divided in half, we have 4 feet, so we have A, B, and C, because once again, our right angle points to our hypotenuse, or C. So this is going to tell me that I need to use the formula A squared plus B squared equals C squared. And when I substitute what I know, I have 4 squared plus B squared equals 13 squared. And then when I simplify this, I have 16 plus b squared equals 169. So once I have to get b by itself, so I'm going to subtract 16 from both sides. This will become 0. And I'll have b squared equals 9 minus 6 is 3. 6 minus 1 is 5. And 1 minus 1 is 1. So once again, we have b, but it needs to be just b. So in order to unsquare this, we have to take the square root of both sides, and we'll get b equals 153 square root. And we will have 12.369. And in the problem, it looks like they only have one decimal place, so we have to look at this. There's only room for one, and then we have to look at the number behind it to see if it's 5 or more. So that will take us to 12.4. And just going to look at these two answer choices. So it gave us that the diagonal length was 13 feet. And since C has to be the longest length, we can automatically eliminate these two answer choices because that's longer than 13 feet. So we know that we have to have something that's shorter than 13. So we're left with this answer here. So there's that page. Now go across. Okay. So Mr. Jenkins deposited $1,250 into an account. He made no additional deposits or withdrawals. Mr. Jenkins earned 4.25% annual simple interest on the money in the account. What is the balance in dollars and cents in Mr. Jenkins' account at the end of 4 years? So I'm going to draw my chart again. So we have simple compound interest total amount. So I equals PRT and A equals interest plus principal. Compound equals A equals P times 1 plus R to the T, and I equals amount minus principal. So this is asking us for annual simple interest but then another thing, so we may initially think, okay, we have to only use this formula, but it's saying what was the balance in dollars and cents. So they're asking for a balance, like just balance equals total amount. So we have $1,250 as our principal. So I equals P equals R. So we have a principal of $1,250. We have 4.25% and time of 4 years. And something to point out with this chart, we have to find this one first. So simple interest first. So we will substitute the formula I equals PRT. And when I substitute, I have 1250 times, again, 4.25 divided by 100, so 0.0425, and then multiplied by 4 years. So here we have, when we multiply all of these across, we're going to see so I equals 212.50. So it says we found I, but they're asking for the total, their balance, and so in order to find the total balance, we have this one here. So we have to take, in order to find A, we have to take I, 212.50, plus our principal of 1250. And something that I saw a lot is that people stopped at 212.50, and that was where the biggest mistake was. So we will have to add 1250 back, and we'll be left with, and now we're going to look at this bubbling sheet. So it said to round to dollars and cents. So we have a positive 1462.5, but we need to add our 0 because it's dollars and cents is to the nearest, the second decimal place. So even though there's only a 12.5 on, or 0.5, I have to add the 0. And then with this one, we need to make sure to fill these in properly. So I'm just going across and filling these in. And I could be filling them in a little more darkly, but this will do for now. That was our total amount, and that was, I had to add back to the interest that I found. Which number below is an irrational number? Okay, an irrational number is, if we remember from the Venn diagram, it is the category that's on the outside. It's in its own category. So irrational numbers have decimals that can't be written as fractions. So I always like to, so this, in the answer choices here, we have, this is 3.93 repeating. So repeating patterned equals rational. So there's that one. And this is just negative 3.5. And so that's also rational. It's a terminating. This is a terminating decimal. And this one, the square root of 64, is 8. And so this is going to start as a natural number. So we're only left with the square root of 15. And so we get, when we take the square root of 15, it's 3.8729833463 207, and it just keeps going. So this is a non-terminating non-pattern. And so our answer is this, D. Okay, which of the following lists are in order from least to greatest? So we have lots of different numbers. So what I'm going to do is I'm going to take, since each of these answer choices, these all have the same number set, I'm going to take each number and I'm going to turn them into decimals and then plot them on a number line. 43 over 5 and negative 5. So least to greatest, meaning furthest, if they're negative numbers, they're going to be the furthest away from zero. Like if I say I have negative $5 and you have negative $12, you would have to be able to determine that even though 12 itself is a bigger number, but negative 12, you actually have less money than me. So with negative numbers, you're going to be the furthest away from zero on the left side. So I'm going to draw my number line here. But first I'm going to take these and turn them into decimals. So this is 8.67. 8.66. And we have negative 2.2, 15. Negative 15 over 7. This equals 2.14, and we have a negative here. 43 divided by 5 was 8.6 and negative 5. So we have up to 8. 1, 2, 3, 4, 5, 6, 7, 8. And negative 5. 1, 2, 3, 4, 5. Negative 5. So when I take these numbers, I'm going to have 8.66, which is the square root of 75. Negative 12.2 right here. Repeating. Negative 2.14. So that's going to be just before this. So that was negative 15 over 7. And 8.6 would be just a little bit before 443 over 5. So our least is going to be negative 5. And then negative 2.2, repeating, and then negative 15 over 7. And then positive 8.6 and 8.6 repeating. So these were your two tricky sets right here. You had to determine which one was smaller. Okay. The set designer for a background scenery on a large piece of plywood, he used a 13-foot pole to hold a piece of plywood upright, as shown in the diagram below. What is h, the total height in feet of the piece of plywood here, round to the necessary 10th place. So they're asking us to find this height here. They give us this small right here is 2 feet. And they give us a right triangle. So we have A, B, and C, right? The angle always points to the hypotenuse. So our formula, a squared plus b squared equals c squared. When we substitute, we're going to have 5 squared plus b squared equals 13 squared. So we have 25 plus b squared equals 169. And then we're going to have to subtract 25 from both sides. And we'll be left 9 minus 5 is 4, 6. We have 144 equals b squared. And we'll have to take the square root of both sides. So b equals 12. And so, of course, they gave us an answer that was this. So the thing that was tricky is that they had this additional 2 feet. So we have to add those 2 feet in order to find the total height. They were looking for the total. So we found up to here, from here to here, was 12 feet. And then we had to add this additional amount in order to get the total height of 14. So B was 12, and then we had to add 2, which would give us B here. Okay, the density of oxygen is 0.00. I'm going to go ahead and 0.001429 grams per cubic centimeter. How is this number written in scientific notation? So here's our key scientific notation. So we're going to have a number between 1 and 10 multiplied by 10 to some exponent. So this is a small number, so we're going to have a negative exponent. So right off the bat, we can eliminate those 2 answer choices because they've already are bigger numbers. So these are positive exponents. So we have our decimal point here, but it needs to be right here because here's our number. Here would be our number between 1 and 10. So we would have to have moved this 1, 2 times. 1, 2, 3 times. My bad. And so we would have 1.429 times 10 to the third, but since it's a smaller than 1 number, we're going to have a negative exponent. All right, looks like this is another one. The mass of a textbook is approximately 0.00165. How is this number written in scientific notation? So we know it has to be the numbers, and they gave all of these numbers like this, and that was a tricky thing that they did. And these are all actually the same number. All of these, when you substitute them, but what you have to remember is that this number here, that's being multiplied by 10 to some exponent, this number has to be between 1 and 10. So our decimal needs to be here, so 1.65. And so that would be molding it 1, 2, 3. 1, 2, 3. So the third, but it has to be negative. In order to have that, we have the one that matches right here. Okay, the Venn diagram shows 3 squares that are joined at vertices to form a right triangle. Which statement is true? So we have our right triangle, and this is pointing to our hypotenuse, or C. Then we have our legs A and B. So A says the sum of the areas of square N and square L is equal to the area of square K. So it's like the little water video that we watched in class. So all of these, the area of this, so A squared and B squared, A squared plus B squared equals C squared. And so when you find the area, length times width, so that is taking A times A squared, so that finds your area. So to me it looks like this is going to be our correct answer. The sum of the areas of square N and square L is greater than this area of square K. No, because they have to be equal. These have to be equal. The sum of the areas of square N and square K is equal to square L. So that's saying that C squared plus A squared equals L squared, which is not correct. And the sum of the areas of square N and square K is less than the area of square L. Less than, remember, they're always equal. And our last problem here says Gabrielle deposits $2,500 into each of two savings accounts. Account 1 earns 4% annual simple interest, and account 2 earns 4% interest compounded annually. So we have simple and compound. So I'm going to go ahead and draw that box that I had earlier. Draw it a little bigger. So we have interest and amount, simple, and compound. So I equals PRT, and A equals I plus P. A equals principal times 1 plus R to the T, and interest equals total amount minus principal. Okay, we're asking for Gabrielle does not make any additional deposits or withdrawals. What is the sum of the balances of account 1 and account 2 at the end of 3 years? All right, so we have IPRT equals 20. Our principal equals 2,500. Our rate is 4%, and our time is 3 years. So here, first we have to find the simple interest. And so we are going to use simple interest. So we have I equals PRT. So I equals 2,500 times 0.04 times 3. And then we will multiply 2,500 times 0.04 times 3. So this gives us I equals 300. But they're asking for the sum of the balances. So balances equals our big A, which is our total. So here, for simple total, we have to take A equals 300 plus 2,500. And so when we add those together, so we have, for this one, we have $2,800. And then it says we also have to find the compound. So we still have I equals PRT up here. So when we have, now we're looking for compound, a formula here. So to find our compound interest, we're going to have to take A equals P times 1 plus R to the T power. So A equals principal 2,500 times 1 plus 0.04. That was taking 4% and divided by 100. And then to the third power. So when I solve this, I'll plug it into my calculator and get 1.04. Our solution of A equals 2,812.16. So what they asked us to do is to find what is the sum total of the balances of account 1 and account 2 at the end of 3 years. So when it says and, we're going to have to add. So we're going to take 2,800 and then we have 2,812.16. And that will leave us with 0.16 when we add. So we have to add right here. And then we have 2,188.6 and then 5. So 5612.16. There we go. All right. So hopefully those things helped and you saw what mistakes you made.